So here's some more trigonometry review. The first of which, in this video, the first thing we will be talking about is the signs of the different trig functions in a given quadrant. And what you'll want to keep in mind is that there are 4 quadrants, 1, 2, 3, and 4. Oops, there we go. And the acronym that you can use to remember this, A, S, T, C, which means in the first quadrant, all trig functions are positive. In the second quadrant, the sine and its reciprocal cosecant are positive, everything else is negative. In the third quadrant, the tangent and the cotangent are positive and everything else is negative. And in the last quadrant, in quadrant 4, the cosine and its reciprocal secant are positive and everything else is negative. So what I like to do is start with the positive angles. So let me see if I can move all this stuff. There we go. So for example, in this first one, part A, I like to deal with the tangent first because it says, find the quadrant in which tangent of theta is positive. Well, I know that's going to be either in quadrant 1, because everything is in quadrant 1 is positive, or in quadrant 3, because that's where tangent is positive. Well, we can't have an angle that is in quadrant 1 and quadrant 3 at the same time. So which quadrant is it? Well, that's where we go look at the second clue. The sine of theta is less than 0, or negative. Well, in the first quadrant, the sine is positive. So it can't be the first quadrant because that means sine would be bigger than 0. So it's not the first quadrant, it ends up being the third quadrant. Down here, tangent is positive, cotangent is positive, and everything else is negative. So the answer is quadrant 3. So in the second example, the cosecant is positive, so I want to deal with that one first. So I know that's either going to be quadrant 1 or quadrant 2. Because cosecant is the reciprocal of the sine, it's got to be one of these two. That's where cosecant is positive. Which one is it? Again, you can't have an angle in quadrant 1 and quadrant 2 at the same time. We look for cosine being negative. Well, the cosine is positive in quadrant 1, which means the answer here would be quadrant 2, because this is where cosine is in fact negative. On this slide, we get really deep into the unit circle. So you can see on the outside here are the measurement of all the angles in degrees. And on the inside here, you have measurements of all the angles in radians. So this one in particular is 0 radians if you're starting out, or if you've gone a full revolution is 2 pi radians. So there's a similar thing happening here. It's 0 degrees if you're just starting out, or if you do a full revolution, it should be listed here as 360 degrees. So this is what the unit circle looks like. A couple other things about the unit circle is that every length here is a length of 1, or 1 unit. That's why we call it the unit circle. It's centered at the origin and has a radius 1 unit. Let's see here. The last thing you'll want to know here is that the first coordinate in every point on the unit circle is the cosine of that particular angle, and the second coordinate is the sine of that particular angle. So from here we can start figuring out what all of these different values are. For example, cosine of pi over 4, I just need to find that angle, that's this one right here, and look for the x coordinate. So this answer here is square root of 2 over 2. Let's jump down here to tangent next, tangent 330 and tangent pi over 2. So these ordered pairs give sine and cosine, or rather in the correct order of the ordered pair cosine then sine, but nothing about tangent. Luckily, we can rewrite tangent as the sine of 330, over the cosine of 330. Those are values that I absolutely know from this unit circle. So I can see the sine of 330 is here, -1/2. And the cosine of 330 is right here, positive square root of 3 over 2. And how do you figure this out? Well, there are a couple ways you can do this. You can know that dividing a fraction is like multiplying by the reciprocal. So that's one way you could do this. Or the way I like to tell my students is to multiply by the LCD of the little fractions, and the little fractions being the little fractions like this. So the only LCD here I have is 2. Those reduce all of the 2's, leaving you with a -1 over square root 3. So there's an answer for that one. And also, we can do this one really quickly here. The tangent of pi over 2. Pi over 2 is up here. So I know cosine is 0 and sine is 1. So let me go ahead and write that out. Sine of pi over 2 over cosine of pi over 2. And I just said that the sine is 1 and the cosine is 0. Oh, except that is undefined. Can't divide by 0, so it is undefined. For these last two, the only thing you can do is relate it back to whatever is sine or cosine. So for the cosecant is 1 over sine of pi over 3. Or if you like to think of it as the reciprocal of the sine of pi over 3. So pi over 3 is here. The sine value is square root 3 over 2. So the reciprocal of that is 2 over square root 3. And the same thing for secant of 45 degrees. So here's 45 degrees. It really doesn't matter which one you pick here, but secant, the secant is the reciprocal of the cosine. So if you're looking for secant, that means you can find the cosine value, which is the x value, and find the reciprocal of it, which ends up being 2 over square root of 2. On this slide, some more evaluating of trig functions. This time with a bunch of negatives on the inside, and then some other oddball ones over here. So with these negatives, if you can remember that there are these formulas up here called the negative formulas, which basically relate to the sine, cosecant, tangent, and cotangent being odd. First the negative is inside, now the negative is outside. So all 4 of these trig functions are odd functions, while cosine and secant are even functions. You get the same thing if you substitute in a value for x or the negative of that value in for x. So how does this work? Well, this sine of negative 150 degrees just becomes the negative of the sine of 150 degrees. And so the sine of 150 degrees is 1/2, so this ends up being -1/2. And we can do something similar here with the cosine. The cosine of -5 pi over 6, well, by this formula up here, if there's a negative inside the cosine, it's the same thing as evaluating the positive value. So cosine of 5 pi over 6, which is negative square root of 3 over 2. The last example to use this these negative properties here. Is this one right here, this tangent of negative 2 pi over 3? Well, that is exactly the same thing as writing the negative tangent of 2 pi over 3. And when I say exactly the same, I mean equivalent to. So the negative tangent of 2 pi over 3. So we just have to know what tangent of 2 pi over 3 is. Well, that's negative. That's the same thing as sine of 2 pi over 3 over the cosine of 2 pi over 3. So the sine of 2 pi over 3 is square root of 3 over 2. The cosine of 2 pi over 3 is negative 1/2. And there's a negative in front of that entire fraction. So this reduces or simplifies all the way down to just square root of 3. So with these last two, we just have cotangent of 315 degrees and the secant of 210 degrees. So these are going to be similar to what's on the previous slide. So for cotangent, you need the cosine of 315 and the sine of 315. Oops, this degree sign should be inside parentheses. So with that, cosine of 315 is square root of 2 over 2. As 315 is in the fourth quadrant, the cosine value is positive. But the sine of 315 degrees is negative square root of 2 over 2. And if you multiply the top and the bottom by 2, all these tiny little fractions disappear. So we're left with the square root of 2 over the negative square root of 2, which just ends up being negative 1. And then lastly, with this secant, this is the same thing as 1 over cosine, 210 degrees. And the cosine of 210 degrees will be negative because 210 degrees is in the third quadrant. Cosines in the third quadrant are negative. So this gives you negative square root of 3 over 2. So on this slide, you're going to be asked to use the calculator to find the values of these four things. So let me bring up a calculator. So here I have the Google calculator, and you might notice that right off the bat you're being asked to find a secant and then a cosecant. But on this calculator and on most calculators, you're just given sine, cosine, and tangent. So similar to previous slides, we need to rewrite anything you're given in terms of sine, cosine, and tangent. So we start out. Secant is the same thing as 1 over cosine. The input is 138 degrees. So I need to make sure that I am in degrees before I figure this out. So in the Google calculator, you can change from degrees to radians right here pretty easily. So I'm going to go ahead and put it into degrees. That's the DEG that you see right here. Oops. Then I'm going to type in 1 divided by cosine 138. And you get negative 1.3456. And you can see up here we're looking for 4 decimal places, so this equals negative 1.3456. And we can do something similar for this with the cosecant. So cosecant is 1 over sine. This is 12.21 degrees. The 12.21 degrees, so let's do that. 1 divided by sine of 12.21. Close it, equals, let's see here, 4.7282. So this is 4.7282. Cool. Well, with this one over here, cosine, this is cosine of 8 pi over 9. And I'm going to tell you, if you don't see a degree symbol, it's radians. So with this cosine of 8 pi over 9, that means I'm going to be over here and I'm going to be in cosine. I need to be in radians. 8 pi over 9. Enter. So this is negative 0.937. So this is negative 0.9397. There's that. And finally, there's this last one over here just kind of hanging out. All this other ink is in front of it, but I think you guys will get the idea here. Tangent of negative 1.7453. And again, there's no degree symbol here, so this is in radians. So tangent, let's see if I can do this. Tangent of negative 1.7453. Close it, equals, so that is 5.6723. This is 5.6723. And so that's it. You just put these on the calculator and you are good to go. So whatever calculator you have available with trig functions on it, feel free to use that. On this slide, we will start the verification processes, but before we do that, I want to go over a little bit of simplification, as that will make the verifying easier. So the simplification here on this left expression means that you are going to FOIL this out. So this will be cosine theta minus sine theta times cosine theta minus sine theta. And this FOILs out to be the following here. But if I rearrange this to move the sine to the very front, I'll have sine squared theta plus cosine squared theta minus 2 cosine theta sine theta. And this brings up the idea of another type of identity here, this Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And the rest of this stuff just comes along for the ride. So this is minus 2 cosine theta sine theta. And that's it. That is the simplification. Now, another good skill to have when going through verifications is to be able to combine two terms if one of them is a fraction. So usually how this is done is recognizing that, hey, this is the denominator that I have. I need to have this term with the same denominator. So let me just go ahead and divide by a sine theta. But in order to keep this term here, this white sine theta, in order to keep that equivalent, we need to also multiply the top by a sine theta. So now the expression looks something like this. Once you're here, you notice that these two fractions have the same denominator. These two fractions can be easily combined into sine squared theta minus 1 over sine theta. And that's it. That's all we want to do for now, is just get used to combining these two things together. What will end up happening is when you see some verifications being done, you'll have a side that will start with two or more terms. Like this, we started with sine theta minus 1 over sine theta, 2 terms. And the point being that it is easier to turn an expression with 2 terms into an expression with 1 term. It's easier to do that than it is to take an expression with 1 term and turn it into an expression with 2. So just keep that in mind as the verifications come over the next couple slides.